Hello everyone, in this video let us try and understand what is pumping lemma. A pumping lemma is a fundamental theorem in automata theory and the study of formal languages. It does not prove that the language is regular, instead it provides a powerful method for proving that the language is not regular. It works by establishing the core property that all regular languages must possess. This property states that any sufficiently long strings within a regular language can be pumped, meaning a central section of the strings can be repeated any number of times or removed entirely, and the resulting new strings will still belong to the language. If we can find even one language that violates these properties, we can definitely say it is not a regular language. This is also called as a proof of contradictions. Okay, so let us see the theorem of pumping lemma. This is to show that the languages are not regular. The pumping theorem for regular languages theorem. If L is a regular languages, then there exists K which is greater than or equal to 1. It means that there should be at least one state. Okay, this is the very first condition. For all string W belongs to the language where the length of the string should be greater than or equal to the K. So this is a condition that is required in order to satisfy, to include all set that should satisfy all criteria. Say suppose if at all we have a language like A star B, at least we should be able to take AAB or AB. So the looping, the element that is there in the loop should also be considered in order to check whether that particular language is regular or not. So that is a way that we have to choose a string length in such a way that that should be greater than or equal to K. And there exists XYZ wherein it belongs to W is equal to XYZ, and we have to divide the strings in such a way that the length of XY should be less than or equal to K. K is the total number of state and Y should not be an empty string. And this is very important. There exists a Q. This is a pumping value should be always greater than or equal to 0. So if at all it is a regular language, then apply this kind of a formula, that is x into y to the power of q into z should always belong to the language. If the given, whenever we are pumping the values to the given set of strings and that particular string does not belong to the language, means hence it is not proving this theorem. Hence it is applying the proof of contradictions and says that it is not a regular language. So this is the proofs of pumping theorem. So let us go to one of the example, that is a standard example, a power n and b power n. So let us see like how we should be able to prove that the given set of the languages are not regular. So let's take this example, example 4.2, that is language is equal to L1 is equal to a power n and b power n greater than or equal to 0, equal number of a's, that is equal number of a's should be followed by equal number of b's. The goal is to prove that the languages are not regular. Let's take the example string. Let us choose one example string. Okay, just let it be like 4 a's followed by 4 b's. For this matter, you should be able to take any example strings of which satisfy this particular condition. The pumping rule. The pumpable part is the y must come from the beginning of the strings. In this case, y must be made of one or more a's. So let us try to split this particular values based on the theorems. Okay, we have a theorems now. We should divide that particular strings into x, y, z. So let us divide this as x, y and z. So here is x, y, z, and we have a formula that x into y to the power of q into z. So according to that, let us try to pump two values. So x into y, q is equal to 2 here, y into z. So x is as it is we have written, and y is equal to 2 times of a will come, and then the remaining part of the strings would be written. Now we can see that we have 6 a's followed by 4 b's. 1, 2, 3, 4, 5, 6 a's followed by 4 b's. Hence, this is applying the proof of contradiction. This does not belong to the language of a power n and b power n. Hence, the languages are not regular. The contradictions. Our new string has a 6 a's but only 4 b's. It no longer has the equal number of a's followed by b's. It breaks the rules of the languages. So conclusion, since the pumping, the string creates a result that is not in the languages. The pumping lemma is violated. Therefore, the language 1 is not regular. So this is how you should be able to prove that the given languages are not regular.